Hello students, a convex lens is a very important device which has so many applications in cameras, in microscopes, in telescopes, and even to improve your sight in glasses. So, and the most important thing about a convex lens is its focal length. And in today's lab, I'm going to explain how you can find the focal length of a convex lens. So we have the lens here, the screen set up here, and the source right here. All these three are set up on the passcode track, and all three are movable. Although I do want you to fix the source at 4 centimeters, and then you're going to move the lens and keep it at a distance of 20 centimeters first. Find the clearest position of the image, then do the same for 5 distances of the lens from the source, and in each case calculate the focal length. You can see that the source is now exactly at 4 centimeter. This is going to be the object, and the vertical one is what we're going to look at. And see, the arrow is on top, and that will let us determine if the image is inverted or upright. Okay, so that's the object. And then we have the lens here, a convex lens. I'm using the lens of focal length 100 millimeter, which is 10 centimeter. And here is the screen. So first of all, I'm going to fix the lens. I'm going to take it to 24 centimeters. I'm going to move it to exactly 24 centimeters. And you got to be very careful because the lens is here as given by this. So you need to take the measurements of the plastic tab inside, which is, I don't know if you can see it, which is what I'm trying to situate at exactly 24 centimeters. Okay. May not be very clear. Let me see. Yeah. So that inside tab is at 24 centimeters. So the source, which is at position A, is at 4 centimeter. The lens, which is B, is at 24 centimeter. And now I have to move the screen and adjust it until I get a very sharp and clear image. And you can see the image coming up now. And you have to determine by looking at carefully the clearest position of the image. So you move it slowly, and then I suggest I'm looking for the lines in between. When that becomes clear, that shows you that it's in the best position. When it's the best position. So that's what I figured out, and you have to move it back and forth until you get the clear position. And for me right now, I think is the clearest because I see the lines too. And that is at, how much is that? That is 43.2. Here you take the measurement of the screen, which is the front face, so it's at 43.2. So that is your position C. So the distance between the source and the lens is the object distance. It's called P. So that distance is going to be 20 centimeters for us, because this was at 4, this is at 24. So that distance is going to be at, P is going to be 20 centimeters. And the image distance is the distance between the screen and the lens, which if you subtract, we had 43.2 minus 24, that gives us 19.2 centimeter. In closing, I want to say that you cannot use the same method to find the focal length of a concave lens. And the reason is a concave lens produces a virtual image. So if you set up a screen, you will not be able to get a real image on the screen. So this method will fail. Of course, there are other methods to find the focal length of a concave lens, and one of the methods is to combine it with a convex lens, which has more power than the concave lens. And in this case, the combination will act as a convex lens, and from there you can calculate the focal length of the concave lens. Well, that's for another time, another day. I hope you understood how to do this lab. Please do turn in the lab reports in the neatest form that you can. So see you all on the next lab. Thank you.